In this video, we're going to talk about impulse and momentum. Momentum is the product of mass and velocity of the body. It is represented as rho is equal to m times v, or momentum is equal to mass times velocity. On the other hand, impulse is the product of the force and the length of time the force acts. It is represented as variable j, wherein it is equal to f times c, or force times time. Remember that acceleration is the ratio of change in velocity per unit of time, and Newton's second law of motion as F is equal to ma, or force is equal to mass times acceleration. If we're going to substitute the change in velocity per unit of time on his equation, this becomes force is equal to mass times change in velocity per unit of time. If we're going to cross multiply time to the left side of equation, this becomes impulse as force times time is equal to mass times the final velocity minus mass multiplied with the initial velocity. Hence, impulse is equal to the change in momentum. The law of conservation of momentum states that momentum lost is equal to momentum gained. When bodies collide, momentum before collision is equal to momentum after collision. Elastic and inelastic collisions, the total momentum before impact is equal to the total momentum after the impact. In equation terms, this gives us m1u1 plus m2u2 is equal to m1v1 plus m2v2. Variables u1 and u2 are the velocities before impact for the first and second masses respectively, while variables v1 and v2 are the velocities after impact for the first and second masses respectively. The coefficient of restitution for any collision between two bodies in which the bodies move only along a single straight line. The coefficient of restitution is defined as E is equal to V2 minus V1 all over U1 minus U2. If the coefficient of restitution, or E, is equal to 0, it is an inelastic collision. Otherwise, if E is equal to 1, the collision is said to be perfectly elastic. We have a sample problem here. A 60-ton rail car moving at 1 mile per hour is instantaneously coupled to a stationary 40-ton rail car. What is the speed of the coupled or attached car? We are given with M1 as the 60-ton rail car, or the mass of the 60-ton rail car, with its initial velocity prior the impact or coupling at 1 mile per hour as U1. The other one, the 40-ton rail car, is represented as M2 with its initial velocity, which is equal to 0 because it is stationary. We are required to determine the speed of the coupled or attached car. So how are we going to do it? We have to illustrate it as like this. The total momentum of the initial impact, okay, we have the first mass with its corresponding initial velocity u1, okay, and then coupling it with the second rail car with its corresponding velocity or initial velocity, and then after coupling both, this gives us a combined mass with single velocity. If we're going to proceed with our numerical solution, the total momentum of the initial impact is equal to the total momentum after the impact. Okay? M1U1 plus M2U2 is equal to M1V1 plus M2V2. Okay? This is the equation for the conservation of momentum. Since we are talking about coupling of both rail cars, okay, this becomes as a single velocity with V1 is equal to V2. If we're going to rearrange now the equation, this becomes m1u1 plus m2u2 equal to the sum of both masses multiplied with its single velocity after the impact or after the coupling or attachment of both cars. If we're going to plug in the values, for M1, it is 60 tons multiplied with its initial velocity, 1 mile per hour, plus M2 at 40 tons multiplied with its corresponding velocity, okay, which was stationary at 0. After the coupling, equal to the mass of both rail cars as 60 plus 10 tons multiplied with its single velocity after the impact or after the attachment at V2. Solving now for V2, we have to divide both sides of equation with 100 ton, which gives us the final answer at 0.6 miles per hour. Now that ends my presentation regarding impulse and momentum. For other sample problems regarding impulse and momentum, please stay tuned with my other videos regarding to the topic.